Topic of this second week of the course is the numerical modeling of particle latent flows, that is, the description of this phenomenon through computer simulations. Why are we so interested in this approach? Let us take a step back. There are two main approaches to solve a fluid dynamic problem, namely physical testing and numerical modeling. Physical testing consists of running experiments, usually at the laboratory scale, whereas numerical modeling means running computer simulations. Both approaches have pros and cons. For instance, experimental tests appear a more direct investigation method, but they are economically expensive. They generally provide only few information, for instance, pressure, flow rate, and temperature, at the locations where the instruments are installed, and they are subjected to size limitations, resulting in non-trivial size upscaling issues. In relation to this aspect, the typical problem is how to use experimental data on a small size prototype of a given device to gather information on the real scale device. On the other hand, computational simulations are free from all these flaws, since, with limited cost, they allow obtaining a lot of information on the actual device without any size limitation. However, in order to be practically usable, computational fluid dynamic models, or CFD models, are approximated in nature, and therefore it is of key importance to guarantee that the approximations made do not adversely affect the reliability of the simulation results. The most direct way to achieve this goal is to perform an experimental validation of the CFD results. That is, to verify that, at least in some conditions and limited to specific features of the flow, the numerical predictions agree with the experimental evidence. Based on this discussion, a synergy of physical testing and numerical modeling appears an excellent approach to problem solving in engineering fluid mechanics. Experimental tests might be first used to validate the CFD models, and afterwards, the same CFD models might be employed to investigate the phenomena of interest. The considerations drawn so far apply to fluid mechanics in general, but they are even more valid for particle latent flows. All the pros and cons of physical testing and CFD modeling are further enhanced if solid particles are added to a liquid phase. Experiments are even more expensive and even more difficult. The mathematical models are even more complex and involve even more approximations. As a result, experimental validation becomes even more important to have some confidence in the numerical results.